Welcome back, everybody. This is our first session in JEE Mains previous year questions for chapter Alternating Current of class 12th. Before this video, we have made several videos related to the previous year questions, and all of those videos are available in the YouTube channel's playlist section. We have also started similar series for NEET. So if some of your friends are preparing for NEET and or you want some additional practice, then you can also watch those videos. If you find these videos helpful, do press the like button, share them, and subscribe to our channel. Also, if you like to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. So with this, let's start today's video with question number 1. Let me adjust pen thickness. So here is a question on the screen. We have alternating voltage, and this is not A, it's actually pi, is applied to a purely resistive load of 50 ohm. Time taken for the current from rise from half of the peak value to the peak value. So we have to find that how much time current is going to take to rise from half of the peak to the peak. Now we know that current is voltage by time. So voltage by resistance. And as there is no other type of element used in the circuit, only resistive load is there. So it will be 220 sine 100 pi t divided by 50. So this is the value of the current, and from this we can say max value. We can write it like further 22 by 5 into sine 100 pi t. So max value of current is equal to 22 by 5 here, and it will be when this whole term is equal to 1. So for us to have a maximum value of the current, sine 100 pi t should be equal to 1, or 100 pi t should be equal to 90 or pi by 2 radian, and from this time is equal to 1 by 200 second. So this is the value of the time, which will be when current is at its peak value. So at this time current will be at its peak value. Now we have to find the time taken for current to rise to half of the peak value. So in that, suppose current is I dash and it is half of peak, so half of I max, and that will be 11 by 5 from this value. So let's suppose time is t1 for this. So we can say 22 into 5 sine 100 omega t1 at time t1, value of current is 11 by 5. So this will be 11 by 5. 5 get cancelled, it will be 11 by 22. So half is equal to sine of 100 omega t1. Now we know that sine is half at 30 degree or pi by 6 radian. So pi by 6 is equal to 100, sorry, that is pi t1, and again pi get cancelled, and from this t1 is equal to 1 by 600. So we have to find the time difference from the this value to the peak value. So here what we have calculated till now, this is the behavior of current here, as this current is following the sine graph. So this is the peak value of the current. This is the peak value of the current, and time taken here to reach this peak value is given by 1 by 200 second. And this is suppose half of the peak value. Here we have time and here we have current. So time taken here to reach is 1 by 600 second. And we have to find time as per question, time taken from to reach the peak value from the half value, means we have to find this time period. We have this time period and we have this time period. So what we do, we can subtract 1 by 1 by 600 from the 1 by 200. So requested time or required time will be 1 by 200 minus 1 by 600, that we can write 3 by 600, it multiply by 3, divide by 3. So that will be 2 by 600 or 1 by 300 second. And we can write it like further 3.3 into 10 raised to the power minus 3 second or 3.3 millisecond. So option D will be the right answer. Let's move to the next one. So a small circular loop of wire radius A located at the center of a much larger circular loop of wire of radius B. Two loops are in same plane. Outer loop of radius B carries a current. This EMF induced in the smaller loop is nearly. So we have to find EMF in the smaller loop. Let's draw two loops. Suppose this is the first loop or the smaller loop, and this is the bigger loop here. We have been given radiuses. This is radius of smaller is A and radius of the bigger is B, and we have a current in the outer loop. Suppose as this current will keep on changing direction as it is a varying current, so I here. Now, as current is varying, so value of magnetic field at the for this smaller loop will be keep on changing, and due to changing magnetic field, there will be change in flux, and due to change in flux, there will be induced EMF. Now, the one condition which we will assume here, that B is very large as compared to A, so that this smaller loop of radius A is just around the center of the bigger loop. As we know that uh, magnetic field at the center of a loop, we know the value, and that is given by magnetic field at center. Suppose the point is O, center point, it will be given by mu node I by twice of the radius, that is B for bigger ring. So this is the value of magnetic field at the center of the bigger ring. Now when we calculate flux, to calculate flux we need area, and we take dot product of magnetic field and area. And if radius of our inner loop is larger, if radius of this loop is larger, then we don't have a definite value of magnetic field, because we only have this formula only works for the magnetic field at the center, not around the center. So we assume that this loop of radius A is very small, so it is just about the center, and then we can take magnetic field at the center to the equal to the magnetic field inside this loop. So this is the assumption we are going to take here, and we have to find induced EMF. So induced EMF is given by, let's first write the flux. Flux will be mu node I by twice of B into pi of A square. And now induced EMF is negative of d phi by dt. So here in this expression, mu, pi, A square, 2b all are constant. Only I is variable according to this relation. So negative mu node pi A square divided by 2b d by dt of I node cos omega t. Now derivative of I node, as I node is constant here in multiplication, so it will come outside, and derivative of cos omega t will be negative sin omega t into omega. So this will be whole, as this will result will turn positive. Mu node pi a square 2b I node omega sine omega t. And if we compare it, first it should be sine, so cos are cancelled, omega sine we have twice here, so option A will be the right answer. Let's move to the next one. A sinusoidal voltage is applied across the pure inductance of this value. Current through the coil is. So we know that current across a inductor lags by pi by 2 radian with respect to the voltage. So we can use that this logic or this concept here, that current across inductor lags by pi by 2 radian as compared to the voltage. So current here will be 100 sine 500t minus pi by 2. So this sine is lagging pi by 2 divided by the impedance of the circuit. Now impedance here we have to calculate, as we assume as mentioned that it is a pure inductance circuit, so there is no resistance, so Z will be equal to XL, and XL is equal to omega times L. Omega is this 500 because it is V node sine omega t. So omega is 500 and L is 2 by 100. So Z value comes out to be 10. So I will be 100 of sine 500t minus pi by 2 divided by 10. 10 get cancelled, 100 get cancelled, so it comes out to be 10 sine 500t minus pi by 2. Now we know that sine 90 minus theta is cos theta. So what we take here? We take the negative common. And sine negative theta is equal to negative sine theta. So 10 sine bracket pi by 2 minus 500t. We can write it like this. And then we can use that sine negative theta is negative sine theta, only cos absorbs the negative sign, so this will be minus 10 sine pi by 2 minus 500t, and now sine 90 minus theta is cos theta, so it will be minus 10 cos 500t. So this will be the answer here. And we can also solve it by one more method, that we know that as this is the voltage applied across the inductor, and we know that voltage drop across the inductor is L di by dt. So this value should be equal to L di by dt. So from that we can write that 100 sine 500t is equal to L, that is 2 by 100 into di by dt. Now from this will be 1 by 50, or di is equal to 50 into 100 into sine of 500t into dt. Now we can integrate it. This term is constant, so we will have integration like this. Now integration of di will be I, and that will be 5000 into integration of sine will be negative of course, so negative cos 500t divided by the 500, so 500 cancel it at 10, so this will be minus 10 cos 500t. So via any of the method you can calculate the value, and you need not to be confused. You might get confused that in the circuits we take that induced EMF across a inductor is minus L di by dt. So this is induced EMF and not the potential drop. There is difference, slight difference, only difference of sign of induced EMF and potential drop. Potential drop across inductor is L di by dt, not negative dl by dt. That is induced EMF. Due to this induced EMF, due to this negative term, due to this induced EMF, this is the potential drop across the inductor. So when you solve any circuit problem, in that case you have to take potential drop across inductor is L di by dt, and in case of induced EMF, when there is induced word, then you will take the negative sign. So with this let's move to the next one. In an AC circuit, voltage applied is this, the resulting current is this. So we can see that current is lagging here by pi by 2 uh, radian. So this is a inductive circuit, and as it is completely lagging by pi by 2 means it is a purely inductive circuit. So we have only inductor here. So we have to find out the power consumed, and power consumed is given by, that is I, current flowing in the circuit, into potential into cos of phi, where phi is the phase difference between voltage and current, and here it is pi by 2. So we know cos pi by 2 is 0, so power consumed will be 0. Option C is the right answer here. Now let's move to the next one. So here, in a uniform magnetic field of induction B, a wire in the form of semicircle of the radius r rotate about the diameter of the circle with angular frequency omega. The axis of rotation is perpendicular to the field. If the total resistance of the circuit is R, mean power generated per period of rotation. So we have to find out mean power, and for mean power what we need, potential and resistance, or current or resistance, and for current we need induced EMF. So basically first we will calculate the induced EMF and then we will move further. So for this let's first draw the diagram with coordinate axis. Let's first suppose these are our x and y, and we have to draw z also. So this is z. Now we have a wire here. So suppose this is our semicircular wire. This is our semicircular wire, and we have magnetic field in the z direction, and our wire is rotating something like this. So its area vector, initially its area vector is out something like this and parallel to the magnetic field. And as it rotates, this area vector keeps on making some angle with respect to magnetic field, and that angle theta will be given by omega times t, where omega is the rotation, angular rotation frequency, and t is the time passed. So the area, as we are taking here area in the vector form, so area vector will be equal to a node, where a node is the original area, that is half of the pi r square into cos omega t. Why we are taking this here? Because our vector is keep on changing due to rotation. So our flux will be, that is B dot A will be, this is the area at any time t, and flux will be B into a node cos of omega t. That is the flux. And from this flux, we can find the induced EMF. Induced EMF will be minus d phi by dt. So that will be derivative of cos will be negative sign, and negative negative will be positive. So it will be p a node omega sine omega t. So this is the value of induced EMF. And now power will be induced EMF by resistance of the circuit. So power will become B square A naught square omega square sine square omega t divided by R. And as we have to find out mean power per rotation, means in one rotation we have to find out the mean power. So mean power will be equal to mean value of this whole expression. And here B is constant, A node is constant, omega is constant, resistance is constant. Only this term sine square omega t, which is changing due to the rotation. As due to rotation, angle between B and A keeps on changing. So value of sine square omega t is keep on changing, and we know that value of sine square omega t, average value or mean value of sine square omega t is half. So this will become B square A naught square omega square divided by twice of the R. Now in the options, the value of area is substituted. So we will put here. Now area of this semicircular is pi r square by 2. So square of area will be pi square r 4 by 4. So b square pi square r4 into omega square by 2 square 4 into 2 8. So 8 of r. So we will have like this. It will be, yes, this one, b pi r square omega whole square divided by 8r. So option B will be the right answer. Let's move to the next one. Alternating current cannot be measured by a DC ammeter because, and the option is, the answer is as already written in the option A, that average value of current in a complete cycle is equal to 0. If we draw a AC cycle here, so this is the AC cycle, and if we take its average value comes out to be 0. And in the previous question, we have taken sine square. So when we square this term, when we square this sign, so it becomes something like this negative part becomes positive, and now we can take average of it, and that average comes out to be exactly half. Okay, so option A will be the right answer. This is sine graph, and this is sine of square graph. Let's move to the next one. Now, a part of a complete circuit shown in the figure here, at some instant value of current is 1 ampere and it is decreasing. So current is 1 ampere and it is decreasing at a rate of 10 raised to power 2 ampere per second. The value of potential between P and Q. So we have to find value potential between P and Q, and we can see as that the direction of the current is from Q towards P. So uh, here we will assign some signs, as current is flowing from the Q and flowing towards the P. So in this resistor, current enters from this side, so this will be positive, and leaves from this side, so this will be negative. For battery, it will stay as it is, negative positive terminals, and for inductor again, current enter from this side, so this will be positive, and leaves from this side, so this will be negative. So now we will write the equation for it, starting with point P. So we will have Vp, potential at some potential at point P is Vp. We assume it Vp. Now negative to positive, so positive, and potential drop across inductor is given by L di by dt. Now we encounter a battery with positive to negative, so we will take negative and battery value is 30. Now we have a resistance that will negative to positive, so positive, and potential drop across resistance is given by I times R. So I is 1 ampere here and R is 2 ohms, so 1 into 2 is 2. Now we have reached to point Q. And we have to find Vp minus Vq. So Vp minus Vq will be, this is minus 28, so this from this side it will be plus 28, minus L, value of L is 50 millihenry, into di by dt. Now as mentioned already here, that this rate is decreasing, current is decreasing at this rate, so di by dt is negative of 10 raised to power 2. So this will be negative 10 raised to power 2, negative negative will positive, and we will have here 5 into 10 raised to power minus 2 into 10 raised to power 2. So this will be 28 plus 5 or 33 volts is the answer here, or is the potential difference between Vp and Vq. Let's move to the next one. AC circuit has a resistance, capacitor and inductor connected in series. So quality factor of the circuit. So we know formula for quality factor is 1 by R into L under root L divided by C. So R is 1 by 100. L is 80 millihenry, so 10 raised to power minus 3, and capacitor is 2 into 10 raised to power minus 6. So this will be 1 by 100, 40 into 10 raised to power 3, or 4 into 10 raised to power 4. Under root of that will be 2 into 10 raised to power 2. So the answer will be 2. So option A will be the right answer here. So with this, we end this video here. Again, if you find this video helpful, useful, then do press the like button, share it as much as possible, and subscribe to our channel. Also, if you want to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. So with this, again, thanks for watching, and we will meet in next video.